Hello and good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to Get Conqueror channel. How are you all, dear? This is going to be a very important session. As a part of Antenna's Maha Marathon series, we are into Antenna's Maha Marathon 16. This is a very unique series where we cover all the concepts of antennas and wave propagation. Bhaskar, good morning. Prakash, good morning, dear. Yes, is the audio, video, everything clear? Yeah, just let me know once. It's Antenna's Maha Marathon is part of Antenna's Maha Marathon series. We are into Antenna's Maha Marathon 16. Before we start the session, let me introduce myself. I am GC Reddy. Worked as motivation speaker pan India from the past 12 years. Expert in field theory and communications. Before we start the class, this is the link for the Telegram channel, for our official Gate Conqueror channel. This is the official Telegram channel through which you can access all the Gate Conqueror faculty. Many exciting things are there to be announced for the Gate Conqueror channel. Very soon, there will be more educators at Gate Conqueror channel. Some very good names are coming up. Very soon, K.N. Rao sir will declare the names, and of course, we'll introduce those people to you. That's the good news from the Gate Conqueror channel. Good morning, Muskan. So, comprehensive coverage of syllabus is about to happen. That's the alignment, and targeting GATE 2023. We can easily complete comprehensively all the subjects because we have enough manpower now. In search of quality manpower, it took some time, but nevertheless, we got some best people. You'll soon come to know about the new hiring at Gate Conqueror channel. Stay tuned. Very soon, K.N. Rao sir will update the new people who are joined Gate Conqueror channel. We are into antennas, and this is Antenna's Maha Marathon series. This is a very special series, dear. Till date, it completed 30 hours of recording or live class in the Antenna's Maha Marathon series. Generally, you take antennas at any level. If you see the content regarding antennas, you will hardly find 7 to 8 hours of content related to antennas. But this is a very unique series. We're almost like we took some 30 hours only on antennas. I can say it's a full comprehensive series. And as far as I know, I've never seen such an antenna series coming up with so many concepts all integrated together. Almost everything about antennas is covered in this particular series. For a quick review, those who are joined new to our session, to know what we offer in Antennas Maha Marathon series, let me explain what we had covered in this Antennas Maha Marathon series. We started up with basic terminology, related to antennas. Current distribution in antennas, how current will flow in antennas, radiation mechanism of antennas. Of course, in radiation mechanism, we have dealt with single wire, two wire and dipole radiation pattern. So how radiation actually happens? We had seen in radiation mechanism of antennas. Am I right? Now, and once we had completed radiation mechanism of antennas, we went through the radiation parameters of antennas. Under radiation parameters, we had seen different terms. The gain, directivity, beam area, radiation resistance, efficiency, and so on. We'd also seen the radiation pattern of an antenna, in which we have discussed about terms like main lobe, side lobe, null, first nulls, front to back ratio, and so on. These are all the basic concepts we have discussed. Yes, good morning, Yadav. Okay? Sorry. Oh, fine. Any doubts you can ask, dear. So we had completed these basic concepts. Then we had seen monopole antenna, and dipole antennas, which both are resonant antennas. Then we had seen antenna arrays, why we go for antenna arrays, dear? We go for antenna arrays in order to improve the radiation characteristics of that given antenna. If a single antenna is not suffice to get the desired gain, directivity, beam area and so on, we try to align two or more antennas of similar type, geometrically and electrically suitably connected, such that the effective radiation of this group or array is increased. Such an arrangement is called as an antenna array. Such an arrangement is called as an antenna array. Antenna arrays, we had seen two element arrays, and we had seen the different cases of two element arrays. Seen broadside array and end-fire array patterns. Of course, we have done all the different 5 case studies. Then we went for n element array. Then we went for binomial arrays. Then we went for end-fire array with increased directivity. That is Hansen and Woodyard array. Which will increase the directivity by approximately 79%. More precisely 78.6%. Hansen and Woodyard array. That was about antenna arrays that we had discussed. Then we have studied the 7 sister antennas. Under 7 sisters, what we have discussed here? What is the first antenna among the 7 sisters? Folded dipole antenna. Yeah. Folded dipole antenna small extension for the folded dipole. Yagi-Uda antenna. Yagi-Uda antenna is also called as super gain antenna or super directive antenna. Then the very famous antenna for circular polarization, helical antenna, horn antenna, microstrip array antenna, sixth one, parabolic reflector antenna, seventh one, lens antenna. These are famously called as the seven sisters. The seven sister antennas. We had completed these seven sisters exclusively in this antennas Maha Marathon series. Besides this, we discussed on resonant and non-resonant antennas, under resonant we have discussed monopole and dipole. Under non-resonant we have discussed V antenna, inverted V antenna, and rhombic antenna. These are also very important topics here. Generally, most of the antenna series, you will not see these antennas. Seven sisters rarely you will find in any YouTube channel. The seven sister antennas and discussion about resonant and non-resonant are very rare. We had covered them exclusively in detailed discussion in the previous sessions of the Antennas Maha Marathon series. Then we had went for antenna measurement, in antenna measurement we had seen measurement of gain, and directivity. Along with that, we've seen the setup required for radiation pattern measurement. That can be any pattern. General setup required for radiation pattern measurement. This also we had covered exclusively. Under measurement of gain, we had seen the first method, also called as three antenna method. We had seen the measurement of absolute gain, the measurement of absolute gain by using two identical antennas. we had seen both these methods. Then we had seen under measurement of directivity, because directivity involves double integral solving, general method will not be useful. Therefore, we go for graphical numerical methods. The graphical numerical methods that we have discussed: orange slice method, and conical cut method. Orange slice method and conical cut method. Any doubts there so far? Anyone? Bhaskar, Prakash, Muskan, Yadav, anyone? Is that clear? Just let me know once. Just confirm the video and audio once. Audio once. One second here. Someone please confirm the video and audio once. Is audio clear? So just confirm the audio once. Once just confirm the audio once. I'm just checking for audio once. Otherwise, someone please confirm the audio. Yes, please confirm once the audio. Yeah, fine. Clear. Anil, thank you. Yeah, thank you. Thank you all. Fine. Fine. One second. Yeah. So, under measurement of directivity, we had seen graphical numerical methods. Under graphical numerical methods, we went for the orange slice method and the conical cut method. See, this is like full and descriptive course here. We can't find specially in detailed explanation of Seven Sisters anywhere on YouTube platform. Neither you will find in detailed explanation about the resonant and non-resonant antennas. And it is also very difficult to find the concepts of antenna measurements. So this we had exclusively covered the Antennas Maha Marathon series by taking out 30 hours of time. Once the antennas was done, we went on with wave propagation. In wave propagation, we had seen principal modes of propagation, which are ground wave propagation, sky wave propagation, and space wave propagation. Ground wave propagation up to frequency of 2 MHz, sky wave between 2 MHz and 30 MHz, space wave 30 MHz to 300 MHz. Frequencies allowed: very low frequencies, and almost all the medium frequencies. It's mostly high frequencies because 2 MHz to 3 MHz is a small window of 1 MHz where medium frequencies are allowed, but mostly high frequency, mostly very high frequencies. In detailed discussion we are starting dear. We are starting. There was some technical difficulties. Our team was into expansion. That's the reason why we got less number of videos. But the good news, I just forgot your name. What is your name, dear? It shows T here. What was your name? What was your name, dear? I'll give you the clarity, dear. You already know that. Amit. Okay, Amit. You already know that in EMFT Module 1 complete playlist is available. Do you know that? Just go through the Gate Conqueror channel. There will be one playlist for Module 1. Module 1 playlist will be there. That is already available, which will cover Module 1 elements of EMF theory, complete syllabus for electrical, for gate and engineering services both are covered in 40 videos with around 50 hours of lecture. Amit, I can say one thing. You go to any YouTube platform, you will not get more than 15 hours of content for elements of EMF theory. Such exclusive content already I had given you. You can just go through. What we need to add is some practice questions here. Some practice questions plus Gate 2022 questions I need to add. That I'll do it very soon. This module 1 is 100% complete. Clear? And regarding, we are asking the number of videos, the consistency of the videos, that will be improved, because the good news is, Amit, we got the complete team for Gate Conqueror now. So we are going to cover comprehensively all the subjects. The frequency will increase. Even Sadish sir is starting today. Couple of days, Hari sir and KN sir will start, and 4 more educators have joined us, so that we can cover up the complete syllabus for electrical and EC. And coming to that, Amit, and coming to that, module 2 is wave propagation. In wave propagation, already I released 6 videos in the playlist. You can see there. We had covered around 10 hours for wave propagation. If you had gone through these videos, these are some wonderful videos we had done. We had completed wave propagation in free space, wave propagation in materials, wave propagation in good conductors, wave propagation in good dielectrics, and wave propagation in perfect dielectrics. Complete analysis is done. Theory was explained. All the problems were done. Numerics were done. What is left out here? 3 topics. Pointing theorem, wave polarization, and reflection and refraction of plane waves. And in reflection and refraction of plane waves, we will see parallel polarization and perpendicular polarization. We will see terms like total internal reflection, Brewster angle, and critical angle. Clear? Amit, am I clear? So this is also done here. You are asking about wave propagation and transmission lines. Wave propagation, I am giving you clarity. This is done. Today and tomorrow we'll finish Antennas Maha Marathon series. Antennas Maha Marathon I need not explain. That is what I was explaining here. Full length comprehensive series. 30 hours of recording is already done. Today and tomorrow approximately some 8 or 9 hours of recording will be done. Around 40 hours will close antennas. Now you can see 50 hours. We got elements of EMF theory. 40 hours will be antennas. Today and tomorrow we'll finish here. Today we have one more session at 9 p.m. on antennas Maha Marathon 17. So mostly by today and tomorrow we'll finish, and by tomorrow 9 p.m. I'll start pointing theorem. I hope you got it, Amit. Tomorrow 9 p.m. I'll start the pointing theorem. So by tomorrow I'll finish antennas. By tomorrow I'll finish antennas. And by tomorrow I will start the residual part that was left out in wave propagation will be added to the playlist. So complete playlist of module 5 is done. Antennas. Module 5 is done. For OFC, I will take separate series. This will be for 8 hours. I will take separate series. That is what I am trying to tell you, Amit. Now we got full team. Me, Sadish sir, Hari sir, K. Rao sir, and 4 more educators have joined. From now you will get some regular videos. Got it? And once this is done, Amit, what you have left out? Module 3 and Module 4, I will start parallelly. Transmission lines and waveguides. Okay? This is a full length comprehensive series, dear, like never before. These many hours of content you can't find anywhere. And if you go through all this playlist, complete EMF will be covered. So don't worry, I understand your pain. But we were also trying our best to keep the videos regular. Okay? And that's my promise now, that we'll do that on a regular basis, because we have the full team now. We have full team now to comprehensively cover the syllabi for all the subjects. Okay, dear. So as a part of this EMF only, because it will take time to cover one by one, parallelly I had started antennas. This antennas Maha Marathon concept was actually to cover the module 5 of EMFT and also cover all the concepts of antennas, such that it will be useful for exams like GATE and engineering services, including all the competitive exams and the PSUs. Communications, after EMFT, I'll start here. After EMFT, I'll start analog communications, full comprehensive series. Later on, I'll extend to digital, then I'll complete. That is around 200 hour full comprehensive series, dear. Starting 200 hour full comprehensive series on communication after EMFT. Right now my prime focus is on EMFT. Communication, definitely you will see some wonderful videos. I will start very soon once this EMFT is done. Okay, Amit? So, under wave propagation, we had covered the principal modes of propagation. It's a ground wave, sky wave and space wave. And my dear, today 9 p.m. will continue antennas Maha Marathon 17. I just want to complete antennas. And the good news is, we'll cover all the PYQs, previous year GATE questions. In antennas Maha Marathon 17 or antennas Maha Marathon 18. But we'll cover the questions. We'll cover the questions for sure. And there will be some extension of antennas Maha Marathon 19 and 20 also, where we'll cover practice questions, but not now. As of now, we'll stop at 18. 18 is almost done. But still, I will try to bring up 100 to 150 practice questions on antennas, which will be exclusively done on YouTube channel, on our channel, in AMM 19 and AMM 20, such that that will be a complete package. From today, channel videos will be regular. Today already 2 sessions of mine. One is now and the other is at 9 p.m. Okay. You inform your friends also, Amit. We got the full team of Gate Conquerors now, with efforts of KM Rao sir. We got the full team. We are ready to go. Okay, dear. I'm really sorry that I understand your pain that you would have waited for the videos. But nevertheless, it got some delayed. But when the video is released, when we go live, we give the best content. So the principal modes of propagation, Sadiq sir is also getting to go, dear. Mostly will take a session today or from tomorrow morning. From tomorrow morning, your favorite rock star, Sadiq sir will be there. He will come back, and very soon, in a couple of days maybe, Ken sir and Hari sir also will join us. So after principal modes of propagation, we have covered special modes of propagation. Under special modes, we have covered scatter propagation. Under scatter propagation, we've gone through tropospheric scatter, and ionospheric scatter. Tropospheric scatter operating between 100 MHz and 10 GHz. VHF, UHF and SHF frequencies. Ionospheric scatter at the lower part of VHF, it's from 25 MHz to 60 MHz. Of course, in detailed explanation, only frequencies I am trying to give here. In detailed explanation already is done in the previous sessions. Under special modes, we also went through the duct propagation, which is a super refraction. Frequency of operation 300 MHz to 30 GHz. Okay. So this is what we have covered. Then we have seen structure of atmosphere, in which we had seen structure of troposphere, and structure of ionosphere, especially ionosphere in detailed explanation was given in our series. That was structure of atmosphere, where we went for structure of troposphere and structure of ionosphere. Then we went for ionospheric abnormalities. We have discussed 10 exclusive points under ionospheric abnormalities. The very important points like sudden ionospheric disturbances, sunspot cycles, sudden ionospheric disturbance also called as Mongol-Dillinger effect. All this we have discussed under ionospheric abnormalities. Then we derived the derivation for refractive index of ionosphere. Under which we had seen mechanism of radio waves bending by ionosphere. We had seen terms like critical frequency, maximum usable frequency, least usable frequency, optimum working frequency. Of course, we have done so much of practice questions also. So many practice questions also in this. Am I right? So probably we are done up to this point. Antennas up to antennas Maha Marathon 15. In 16, we'll continue with the derivations related to the range of space wave propagation and electric field strength of the space waves. Will be followed by concepts like fading and path loss calculation and lot of practice questions and previous year questions, which will comprehensively complete antennas Maha Marathon. And I promise that around 100 to 150 more practice questions will also be added in the later on sessions like antennas Maha Marathon 19 and 20. Is that clear? Everyone, is that clear? Yadav, Anil, Amit. Fine. Any doubts? Let me know, dear. Any doubts? Let me know. Fine. So as I told you, under wave propagation, it covered the principal modes of propagation, in which we had covered ground wave propagation, frequency up to 2 MHz, sky wave propagation or ionospheric propagation, frequencies 2 MHz to 30 MHz, space wave propagation or line of sight propagation. Frequencies between 30 MHz and 300 MHz. Under special modes of propagation, we had covered scatter propagation, in which we had covered ionospheric scatter and tropospheric scatter. And we had seen duct propagation or super refraction. We had seen structure of atmosphere, in which we had seen structure of troposphere and structure of ionosphere, especially in detailed explanation about the structure of ionosphere we had seen in the Antennas Maha Marathon sessions, which was one of the highlight. And we had seen the derivation for refractive index of ionosphere. Very important engineering services question. We had covered and we had seen the derivations, mechanism of radio waves, bending by ionosphere. We had seen the derivation for the critical frequency. We had seen the expression for the virtual height, the critical frequency. We derived 9 root nm, refractive index of ionosphere n or mu, which is sin I by sin r, under root of 1 minus 81 n by f square. Fc is 9 root nm. Nm is in per meter cube, per cubic meter, and Fc is in megahertz. We have seen the virtual height, which is greater than the actual height. Let's see the derivation, the formula Ct by 2. Let's see maximum usable frequency, Fc into secant I. This was secant law, indicating that FMEF is always greater than Fc. We got FMEF is equal to Fc into under root of 1 plus d by 2h whole square. When earth is flat, we have derived this also. We have seen what is least usable frequency and what are the conditions which will restrict for us to decrease the frequency further. We had skip distance. We had explained the concept of skip distance and the derivation. We got skip distance. D skip is 2h into under root of FMU by Fc whole square minus 1. We have also seen the optimum working frequency, which is 85% of maximum usable frequency. All this very in detailed explanation we have done here in the previous sessions of Antennas Maha Marathon series. We had gone through antennas, ionospheric abnormalities, as I told you. We have discussed about 10 exclusive points here. The most important, sudden ionospheric disturbances, also called as Mongol-Dillinger effect. This is due to the formation of solar flares, due to gigantic emission of hydrogen from the sun. We've seen ionospheric storms and sunspot cycle. Out of the many ionospheric abnormalities we have, the first 3 are very dangerous. SID, sudden ionospheric disturbance, ionospheric storms and sunspot cycles. Later also will have some effect, but lesser effect than the first 3. We've seen tides and winds, effect of tides and winds on ionosphere. Fading, we had seen the different kinds of fading like selective fading, interference fading, absorption fading, polarization fading and skip fading. Skip fading is basically a concept where we'll get the decrease in the signal strength or loss of signal strength when you are into the skip distance. We've seen Wechsler's and how they affect. We've seen Luxembourg effect, ionospheric cross modulation, where first time the users of Luxembourg station were able to hear the Paris station as background, as it was first observed by the Luxembourg users. The technical term ionospheric cross modulation is also called as Luxembourg effect, which happens when a low frequency station is in between our station, between the transmitter and our station. If when there is a low frequency station operating in between that, there are chances that this frequency, the intermediate or the physically the station which is in between the transmitter and the station, that station background can be heard as a background of high frequency station. This is called ionospheric cross modulation. This phenomenon was first observed by the users of the Luxembourg station, where they were able to hear the Paris station as a background. So therefore, this is called as Luxembourg effect. Then we have discussed about the statics, naturally formed noise, and we have seen about man-made noise, solar proton events or polar cap absorption. It's in ionospheric absorption, where we have seen non-derivative at lower heights and derivative absorption at higher heights. Here mu is approximately 1, here mu is far less than 1. Now we'll see. In this session, we'll continue with the range of space wave propagation. The idea of explaining the complete concept is, if someone is joining now, they should know what we had covered in the antennas Maha Marathon series. And almost we are to the flag end of concluding the antennas. Is it clear? Yes. Let me know, dear. Is that clear so far? Now we'll start the most important range of space wave propagation. When we are using line of sight propagation, up to what distance we can transmit the signal is derived in this particular derivation of range of space wave propagation. Curvature of the earth, center of the earth, radius of the earth, 6,370 kilometers. This is R. This is also R. This is given by R. This is also R. This is the transmitting antenna. say the maximum range. This is the receiving antenna. Remember dear, the height of transmitter HD, the height of the transmitter HD, good morning Bhaskar, and height of the receiver HR, both are in meters. Both are in meters, whereas R is in kilometers, 6,370 kilometers. If you see the diagram, it looks like almost they are comparative, but it is not the case, dear. Remember, this R is the true radius of the earth, which is 6,370 kilometers, whereas HD and HR are in meters. So I am trying to graze through the surface. This is the maximum line of sight distance. This is D1, this is D2. Therefore, this curve and this are approximately same. This is D1 and this is D2. Total range D is equal to D1 plus D2. Why I am saying this? Because this is a very small height. These both are approximately same. Total range D is D1 plus D2. Clear? Now, if you take these points, this is A, this is B, and this is C. If you take the triangle AOC, it's a right angle triangle. Applying Pythagoras theorem, this is 90 degrees, one opposite to 90, that must be your hypotenuse. So what do you get here? HD plus R is your hypotenuse. Applying Pythagoras, HD plus R whole square is side square plus side square. R square plus D1 square. HD square plus R square plus 2 HDR is equal to R square plus D1 square. R square and R square get cancelled. HD square plus 2 HDR is equal to D1 square. R is a very large value, 6,370 kilometers. HD is in meters. When compared to 2 HDR, HD square is very small value. So this can be neglected. This can be neglected. D1 square is equal to 2 HDR. D1 is under root of 2 HDR. Similarly, applying the Pythagoras on triangle COB. Triangle COB. HR plus R, this is 90. One opposite to 90, this is hypotenuse. HR plus R whole square is D2 square plus R square. HR square plus R square plus 2 HRR is D2 square plus R square. Cancelling out R square. HR square plus 2 HRR is D2 square. Again, when compared to 2 HRR, HR square is a very small value, therefore neglect it. D2 is under root of 2 HRR. Clear? Range is given by D, which is D1 plus D2, that is under root of 2 HDR plus under root of 2 HRR. R is 6,370 kilometers. Under root of 2 into 6,370 into 10 power 3 HD, under root of 2 into 6,370 into 10 power 3 into under root HR. This is under root of 2 into 6.370 into HD plus under root of 2 into 6.370 into HR 10 power 6 under root 10 power 6 will come out as 10 power 3. The range is under root, this is 12.74 under root HD plus under root HR 10 power 3 kilometers. Under root 12.74 is 3.57 under root HD plus under root HR kilometers. That is the range of space wave propagation. As we took some approximation here, we had neglected these values. Therefore, for practical considerations, we can also take the formula as 4 times of under root HD plus under root HR kilometers. Clear? Therefore, the range of space wave propagation is given as 3.57 times under root HD plus under root HR kilometers. The range is given in kilometers with HD is height of the transmitting antenna, given in meters. Remember meters, remember please, meters. HR height of receiving antenna in meters. The range is given in kilometers. Now, what is the practical possibility here? Bhaskar, Amit, anyone? What is the practical possibility here? How much height you can take transmitting antenna and receiving antenna? Tell me. How much height we can take the transmitting antenna and receiving antenna? How much height we can take? Anyone? practically height of the transmitter or the height of the receiver will not be more than 100 meters, not possible more than 100 meters. If you take the maximum height, possible height, practical height possible, then the range will be 3.57 times under root HD plus under root HR kilometers. Under root 100 is 10, 10 plus 10, 20. 3.57, 20 kilometers. 71.4 kilometers. That's the maximum range. If you take the approximation formula, that is range is 4 times of under root HD plus under root HR, then get maximum 80 kilometers, not more than that. It's the maximum range. For line of sight propagation, very important conclusion here. What it is concluding is very important. That if you, that means whenever you are using a line of sight communication on the earth surface, it cannot extend more than 80 kilometers practically. A line of sight link cannot be more than 80 kilometers. You need a repeater at a max after 80 kilometers. Based on the terrain where you are using, this may fluctuate 5 or 10 kilometers, but the approximate range is that. That is why when you are using line of sight communication, after every 50 kilometers, we use a repeater. We use a repeater after every 50 kilometers. Because practically the theoretical value is 70 to 80 is the maximum range of line of sight. But when you are using this line of sight practically, what happens is, dear, because the earth structure, terrain will not be the same. There are so many ups and downs. So basing on that also, your line of sight will be affected. Therefore, practically after every 50 kilometers, we will use a repeater. Got it, everyone? That's a very important derivation for the range of space wave propagation. In the conclusion, we need a repeater after every 50 kilometers because the practical value of this range is around 71.4 kilometers, but with approximation 80 kilometers. Practically, we use a repeater after every 50 kilometers. Everyone, is it clear? Okay. Let us do this numeric. A company operating taxi cabs communicates from its central office with the help of an antenna at the top of a 16-meter tower. That means what? The transmitting antenna effective height is 16 meters. The antenna on the taxi cabs is 1.44 meter. Receiving antenna is 1.44 meter. The communication distance between the central office and the taxi cab cannot exceed. Cannot exceed. That means he is saying what is the maximum line of sight distance that is possible between the taxi cab station and the taxi for the communication to be stable. So that gives you the range of line of sight, as I told you. And you can see all the values are less than 70. You cannot guess. If you take 3.57 under root HD plus under root HR kilometers, substitute, calculate and tell me dear. 3.57 under root 16 under root 1 1.44 kilometers. 3.57 under root 16 4. Under root 1.44 1.2. 3.57 into 5.2. Calculate and tell me the answer here. I'm calculating. You also calculate. Calculate and tell me the answer. .564 kilometers. 18.564 kilometers. Fine. So 18.564. The closest value is 18.6 kilometer. Option A is the answer. Option A is the answer. Even if you take 4 times formula, 4 times under root HT plus under root HR kilometers, even then the value is 20.8 kilometers. The closest value is this. But anyways, in either the case, the closest value is this. Option A is the answer. Yeah. Is it clear, everyone? Everyone please respond. Is that clear? So next we'll see, after the wonderful derivation, range of space wave propagation, we'll see effect of Earth's curvature on space waves. What is the effect of Earth's curvature on space waves? Case 1. Let me consider Earth is flat. Earth is flat. Transmitting antenna. Receiving antenna. Second case, Earth has curvature. Transmitting antenna. And the receiving antenna. Earth is flat, the direct wave. This is the indirect wave reaching the receiver. After reflecting from the Earth's surface. This is the direct wave. This is the indirect wave. This is the direct wave and this is the indirect wave. And here this is the direct wave. This is the indirect wave. This is the direct wave. And this is the indirect wave. The direct wave and this is the indirect wave. Now let me see what is the effect of Earth's curvature on space waves. If you see the first case, when Earth is flat, this is the direct wave and this is the indirect wave. You know the resultant wave is the sum of direct wave and indirect wave. And you know, indirect wave is always out of phase from the direct wave. Therefore, if the indirect wave is stronger, it actually subtracts. Resultant wave will be weaker and vice versa. Therefore, the resultant wave and indirect wave are inversely proportional. If one increases, the other decreases. Now, in this case, the first case, when Earth is flat, the indirect wave is traveling more distance. Therefore, indirect wave will be weak because it has traveled more distance here. This fellow has traveled less distance, strong, less attenuated. This is more attenuated. Therefore, this signal will be weak, implying the resultant signal will be strong. Implying the resultant signal will be weak. That's the first phenomena. Second, it has traveled long distance, but it is hitting on a flat surface. Therefore, the signal will not distract. Complete signal will be reached to receiver. In that case, it is a strong signal. This fellow has traveled less distance, but it is not hitting on a flat surface, it is hitting on a curve. Therefore, diffraction takes place. Only a small amount of the wave will go here. Therefore, this is a weak signal. These two phenomena are equal and opposite. This is strong, making resultant weak. This is weak, making resultant strong. Try to understand. These two phenomena are equal and opposite in nature. Therefore, if you take this case or this case, there won't be any change in the received signal strength. Therefore, for received signal strength of space waves, we can consider the earth to be flat because there is no effect on the received signal strength. The curvature of the earth's curvature will not have any effect on the received signal strength. In both the cases, you are getting equal value. Now just tell me, is that clear? Everyone, is that clear? Just let me know. Any doubts so far? So what's the conclusion? The conclusion is there won't be any effect of Earth's curvature on the received signal strength of space waves. Clear? Next, the most important field strength of space waves. Field strength of space waves. As we discussed just now, there won't be any effect on received signal strength or received electric field. The curvature of Earth will not have any effect on the received signal strength. That is just now I had concluded this thing. Now we are calculating the field strength or the received signal strength in space waves. But we already know that the curvature of the Earth will not play any role or will not have any effect on the received field strength of space waves. So in order to calculate the field strength of space waves, we can consider Earth to be flat because it will not have any effect. And if you consider Earth is flat, the calculation will become pretty simple. Got my point here, everyone? So we can comfortably take the Earth to be flat in the calculation involving the received signal strength calculation of space waves. The most important topic for engineering services mains. Along with this, the derivation for refractive index of ionosphere is also very, very important. Other topics are also important, but these two are very, very important. Okay? This is, I'd consider the Earth is to be flat. Consider the Earth to be flat. This is a transmitting antenna. This is a transmitting antenna. Given by T prime receiving antenna given by R prime. Transmitting antenna given by T prime. Receiving antenna given by R prime. Transmitting antenna having height HT. Receiving antenna having height HR. Distance between the transmitter and receiver is D. This is line of sight communication. Therefore, there are two kinds of waves in line of sight communication as I explained before. One is the direct wave reaching directly from the transmitting antenna to the receiving antenna, covering a distance of D1 for suppose. Other is an indirect wave reaching the receiver after reflecting from the earth surface. This is indirect wave with distance D2. With the distance D2. Now, for a calculation, let me take an image here. Let me consider the image of this antenna. Image of this antenna. Fine. If this distance is D2, if this distance is D2, one second. Okay, give me 1 minute here. Draw this again. This earth is flat. Height of the transmitting antenna, height of receiving antenna, the direct wave reaching from transmitter to receiver, indirect wave reaching after reflection. Indirect wave reaching after reflection. This is the image. Now you will get perfect. This is the image height. Okay? Now it is good, am I right? This is the image height. Now let me take the points. T prime having height HT, R prime having height HR. This is HR. This image is also HR. It's falling on point B. Trying to erase this. Yeah. This is HR. This is also HR. The distance between transmitter and receiver. This is D. Direct path distance D1. Indirect path distance D2. If this is D2, this line is also D2. This is D. And if you take the projection, onto this point, let it be M prime. Try to identify two triangles here. One triangle T prime, R prime, M prime. The other triangle T prime BA. Can you observe two right angle triangles here? Everyone? Are you able to observe two right angle triangles here, dear? Let me know. This is HR, this is also HR, then this complete height will become HD plus HR, this complete height. That is T prime A will become HD HR. T prime M prime, this is HD and this is HR. If this is HR, this is also HR, then T prime M prime will become HD minus HR. Which is T prime M prime will become HD minus HR. T prime A will become HD plus HR. Is that clear? Now identify these two right angle triangles. Okay? From triangle T prime, R prime, M prime, now this is D2, this is D and this is HD plus HR. Hypotenuse square is side square plus side square. D2 square is HD plus HR whole square plus D square. D2 square is D square, if you take common, 1 plus HD HR by D whole square. Taking the root, D2 is D times one plus HD plus HR by D whole square whole power 1 by 2. Applying binomial, applying binomial, 1 plus x whole power n is 1 plus nx plus n into n minus 1 by 2 factorial x square and so on. If you take the higher order terms, ht plus hr is a very small value when compared to the distance between them, which is in kilometers. ht plus hr sum will be in meters. Therefore, this fraction ht plus hr by d is a very small value. If you take the square of it, it will become still smaller. Therefore, all the higher order terms can be neglected. Higher order terms are neglected since ht plus hr is far less than d. Yeah, is it clear? Now, that implies if you neglect the higher order terms, d2 is equal to d times 1 plus x whole power n, 1 plus nx, ht plus hr whole square by 2d square. Only 1 plus nx are there, higher order terms are neglected. Multiplying the d inside, d2 is d plus ht plus hr whole square by 2d. Let this be 1. The procedure is very simple, dear. The direct wave and indirect wave are traveling different distances. Therefore, first we need to find the path difference as we have done in antenna arrays. After we find path difference, we need to find the phase difference, which is beta times of path difference. Then we'll find the total phase difference theta, because total phase difference includes the phase difference due to path difference as well as phase difference due to reflection. Then we'll find total electric field strength. That's the procedure, dear. First step, we must find path difference. Then we'll find phase difference, beta times of it. Then we'll find total phase difference, including reflection of earth. Then we'll find received electric field strength. Then we'll find the received electric field strength. Now this is D2 got. If you consider the triangle T prime, R prime, M prime, sorry. Previously we got T prime BA plus no, this T prime BA, bigger triangle, T prime BA, yes, correct, T prime BA. Now I am considering smaller triangle, T prime, R prime, M prime, T prime, R prime, M prime. This smaller triangle I am considering, hypotenuse square, side square plus side square, hypotenuse 1 opposite to 90, that is D1 now. D1 square is side square HT minus HR whole square plus D square plus D1 square is D square times of 1 plus HT minus HR by D whole square. D1 square is, rather D1 is taking root on both sides, D time 1 plus HT minus HR by D whole square whole power 1 by 2. Applying binomial theorem again, taking the binomial expansion 1 plus x whole power n, neglecting the higher order terms. Again, hd minus hr is far less than d. Therefore, neglecting the higher order terms, we get after expansion d1 is d times 1 plus hd minus hr whole square by 2d square, multiplying d inside, d1 is d plus hd minus hr whole square by 2d. Got it, everyone? Now by doing this, what we got is, we got d1 and d2. By doing this, what we got is d1 and d2. Okay? Now once we are having d1 and d2, we can find path difference. From there we can find phase difference, total phase difference, then we can find ER value. Okay, is that clear? So let me note down what we got here. We got d2. d2 is equal to d times 1 plus hd plus hr whole square d2 is d plus hd plus hr whole square by 2d. This is 1. And d1 is d plus hd minus hr whole square by 2d. What I told you, what is the procedure? Procedure is first you find path difference. Then from path difference find phase difference. From there find total phase difference. Then ER value. Path difference. Difference in the path they traveled. Path difference is given by PD. Path difference is d2 minus d1. That is d plus hd plus hr whole square by 2d minus of d plus hd minus hr whole square by 2d, which is minus d minus of hd minus hr whole square by 2d. D and minus d cancel. hd square plus hr square plus 2 hd hr by 2d minus of hd square plus HR square minus 2 HR by 2D. Multiplying the minus inside. HD square plus HR square plus 2 HR minus HD square minus HR square minus of minus plus 2 HR by 2D. Therefore, path difference is 2 HR plus 2 HR. 4 HR by 2D, which is 2 HR by D. This step is done. Path difference I got. Then tell me how to find phase difference, dear. How to find the phase difference? We got path difference, then how to find the phase difference? Phase difference is beta times the path difference. It's beta times 2 HR by D. Beta is 2 pi by lambda. 2 pi by lambda times of 2 HR by D. Therefore, phase difference is 4 pi HR by lambda D. This phase difference is given by alpha. Therefore, phase difference due to path difference alpha is given by four pi HR by lambda D. Clear? So we got this second step also, phase difference. Now find the total phase difference. Because it is a space wave propagation, there will be direct wave and indirect wave. Indirect wave will come after reflecting from the earth surface. Therefore, there will be phase difference because of the reflection also. Therefore, total phase difference theta is alpha plus beta, where alpha is phase difference due to the path difference and beta is phase difference due to reflection by earth. Generally it will be equal to 180 degrees standard. Therefore, theta is pi plus alpha. Therefore, now the total electric field strength is the sum of direct wave and indirect wave. Therefore, the received electric field strength is sum of direct wave. Let it be having amplitude of E naught, phase difference 0, e power j0. Reflected wave, k times E naught, k is reflection coefficient. E power j, total phase difference theta. I want to find this theta, that is the reason why I had completed all that values first. I got my theta ready so that I can substitute here. So received electric field strength. Now let us see the procedure. In procedure we got total phase difference also. Last step, finding the magnitude of received electric field strength. Received electric field strength E naught plus k times of E naught e power j theta. That is E naught times of 1 plus k times of e power j theta. That is E naught plus 1 plus k times of e power j theta cos theta plus j sin theta. It is E naught times of 1 plus k cos theta plus j times of k sin theta. So express J waveform. If you find mod of ER, magnitude of received electric field strength, E naught times of under root of x square plus y square 1 plus k cos theta whole square plus k sin theta whole square. That is received electric field strength mod of ER is E naught times of under root of 1 plus k square cos square theta plus 2k cos theta plus k square sin square theta. This can be written as mod of ER is E naught times of under root of 1 plus k square times of cos square theta plus sin square theta plus 2k cos theta. This is E naught times under root of 1 plus k square cos square theta plus sin square theta 1 plus 2k cos theta. But you know that k is reflection due to the Earth's surface. If you consider the Earth to be perfect, reflection coefficient is considered as 1. E naught is 1 plus 1 plus 2 cos theta. E naught is under root of 2 plus 2 cos theta. Therefore, mod of ER is E naught times of under root of 2 plus 2 cos theta. This is root 2 times of E naught under root of 1 plus cos theta. Half angle formula, root 2 times of E naught under root of 2 cos square theta by 2. Root 2 will come out, root 2 into root 2, 2 times E naught cos of theta by 2. But you know, theta is pi plus alpha. Substituting 2 times E naught cos of theta is pi plus alpha by 2. Okay, 1 second here. Okay, is it clear? Is it clear, dear? Okay, half angle formula we had used. So, mod of ER is 2 times E naught This is 2 times E naught cos of pi by 2 plus alpha by 2. There is mod here. So no effect of negative value. 2 E naught cos of 90 plus theta minus sin theta, but no effect there. Sin alpha by 2. Mod of ER is 2 E naught sin alpha by 2. But alpha is, already we have derived alpha value, 4 pi HD HR by lambda D. Very clearly, D is a very large number. HD HR are very small numbers. Alpha itself is practically very, very small. So for smaller values, sin theta is equal to theta. Sin alpha by 2 will be equal to alpha by 2. 2 and 2 get cancelled. Mod of ER is E naught times of alpha, which is 4 pi HD HR by lambda D. When E naught is initial electric field strength given by 7 root P by D. P is the transmitted power. Substituting received electric field strength 7 root P by D 4 pi HD HR by lambda D. This is 28 pi root P HD HR by lambda D square. 28 times of pi approximately. This mod of ER is 28 pi is approximately 88 root P HD HR by lambda D square. This is the expression for received electric field strength for space waves. Very, very, very important derivation for engineering services. Is that clear? Fading, this will be continued by fading, path loss calculations, and practice problems and previous year questions of antennas covering gate and ESC. This will be the continuation topics dear. Fading, path loss calculation and practice problems and previous year questions. We'll continue the session today at 9 p.m. Okay? Unacademy has two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches, and crash courses. In Iconic, we'll have all these features. Along with that, we'll have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 1 hour, preparatory study material, that is specialized notes and practice sets, personalized test analysis focusing on your weakness and trying to improve them, study booster sessions in the form of workshops, and a customized study planner that suits you. All this in Iconic subscription. If you're going for a Plus subscription or an Iconic subscription, then you can go for a no-cost EMI. The total cost will be divided by number of months. It's student friendly, and also you can use our team code KNR10. This is our team code here. We believe in team code. And once you apply our team code, not only that you will get 10% off, but also the complete team of Gate Conqueror will be with you. The complete Gate Conqueror team, including the legendary KN Rosa, will be with you people in your preparation. So that's the power of team code. Our team code KNR10 you can use for plus subscription and Iconic subscription. In Iconic, as you know, you get 1:1 live mentoring, which improves your chance of getting a top rank. Because you can connect and avail 1:1 time with the mentor, and you can pre-book the slots with the mentor in convenient time. You can solve your doubts, discuss exam strategies and more with the mentor. Personalized guidance and feedback will be given. This customized study plan will be given, improving your chance of getting a top rank. And 27th of February, that is Sunday, 11 a.m., you have the Gate and ESC Mega Combat, where you can, this combat is nothing but a live quiz competition where 20 questions will be there. 60 minutes will be given. Separate paper will be there for mechanical, civil, electrical, EC and CSIT. And if you have this knowledge, if you have the talent, attempt the combat, and everyone who is attending the combat, participate in the combat, will get 20% scholarship. And those who top will also get almost 100% scholarship or free subscriptions. And not only that, 500 lucky participants will also stand a chance to win all these prizes. And you can enroll by using our team code KNR10. I repeat it. We use the team code KNR10. Complete team support will be there with you. And if you are having any doubt in your preparation journey, subscription and latest offers, you can call our counselor. And remember to use the code KNR10, our team code for taking subscription. Unacademy has introduced a feature called Ask a Doubt feature, through which you can ask unlimited number of doubts. At a go, you can solve 3 doubts. You can get the solution in your preferred language. And also it is very, very easy to upload your doubt, which is simply click, crop and submit. This is a super combo offered here. With every 2-year subscription, we are giving away 1-year subscription free for campus placement and IT jobs. With every 1-year subscription, we are giving away 6-month subscription for campus placement and IT jobs. This is a rank predictor, which is available now. Those are attempted GATE 2022. Just log in or sign up with Unacademy. Go to GATE landing page. Click on the rank predictor banner. This is the link here for the same. Select your stream. Select the session you had appeared. Paste the URL. Your rank will be displayed. These are the special class features. Special class features includes interactive live classes, polls for the learners, raise the hand option. You never miss a class when the notification is on. The lecture notes you can download then and there after the class is done, and you can access anytime and anywhere. We are introducing community here, through which you will never miss any update from your favorite educators. You can download the session notes and practice material, and also you can give the feedback directly to your educator via polls. These are the new batches. Resilience. These are all started at 16th of February. You all know that every week we start 8 to 9 batches. These are the new batches. Resilience GATE 2023 for electrical, explained bilingual. Resilience GATE 2023 for ECE, explained bilingual. Ascend GATE 2024 for ECE, explained bilingual. Ascend GATE 2024 for electrical, explained bilingual. Evolve GATE 2023 for electrical, explained bilingual. Evolve GATE 2023 for ECE, explained bilingual. These are the new batches. For all this, you can use our code KNR10. This is the team code. Remember, by using team code, the complete team will support you. We don't have individual codes. We have team code. Thank you all. And do not forget, if you are new to the channel, do not forget to subscribe, like the session, and Also share the session, which is very, very important. Sharing session is very, very important so that our good work and hard work will reach to the maximum students. Thank you and all the best.